1. Okay, sorry, I'm trying to video too again because my people aren't here. Okay, so we see this, we call this volume 1. Okay, that's not I, it's a 1. And then it says at 27 degrees Celsius in 0.9 or 987 atmospheres. What are these? That's temperature 1, but it can't be expressed in Celsius. It has to be expressed in Kelvin. And this is pressure 1. Okay, when reporting her data, she will have to adjust her conditions or her volume to STP conditions. Now, this is actually telling you 2 more pieces of information. This was our warm-up. What does it tell you? It tells you P2, and that's going to be 1 atmosphere. And I'm choosing atmospheres because what was P1 established in? Atmosphere. So I need to keep constant variable units if I can, because if not, it's going to mess up my math. Okay? And then the other condition that STP gives you is what? But I can't use Celsius, so I have to use T2 is 273 Kelvin. Okay, so I have V1, T1, P1, and then I have given STP conditions, which is P2 and T2. What am I solving for? V2. What law is that? Combined gas law. Okay, I'm expecting you guys can tell me those. I'm going to write those down low because I don't have any space to work here. So, what was P1? 0.987 ATM. What was V1? 250 milliliters. What was T2? T1, sorry. So 27 degrees Celsius is 300. Is that right? What's 300? 300 Kelvin? 27, 273 plus 27. 300. Just making sure we know how to get there. And then what was P2? 1 atmosphere, because that's what STP means. What was T2? 273 Kelvin, which was what STP is. So we're solving for V2. Okay. Hot dog. We got a lot of variables to work with, but they're all very easy equations, especially if you know Boyle's, Charles's, and Gay-Lussac's, because they all combine together to make the combined gas law. Okay, so this information gets me to see the combined gas law, which is what? P1 times V1 over T1 equals P2 times V2 over T2. And I'm solving for V2. You guys tell me, what are you comfortable with? Floppy dot copy? Or cross multiply and divide, bow tie, or just isolate it? Just wing it, but I want to make sure you know what I'm talking about. I like to cross multiply and divide. I'm going to show you how to cross multiply and divide. Okay, so I had so many responses, I chose this way. So cross multiply means this variable situation times this variable situation equals these variables that are multiplied by each other. So that's P1V1 times T2 equals this stuff. P2V2 times T1. Okay, haven't quite isolated yet, but I'm really close now. What do I have to do? Divide by what? So divide both sides by what? P2 and T1 to isolate V2 by itself. So that's called cross multiply and divide. Same situation as the other stuff you guys like. So I learned it this way, so you guys are going to have to pick up what's best for you. But this allows me to cancel P2 and T1 on one side, isolating V2 by itself. This method is good for everything. And your method should be too, as long as you're confident. So literally, V2 equals all that over all that. Okay? So if you don't like that, cross multiply and divide, then trial run with another version. Let's make sure we got the same answers. I'm just rewriting it so I can plug my variables in. Not quite pointing at what I'm writing. There you go. have you start if I can. In just a minute. Let me finish this problem. T2. So atmospheres cancels, Kelvin cancels, milliliters is left. That's great because that's a unit of volume. And what did you guys get? Say again? 225. We still have 4 minutes left in class. You should not be you should not be packing up. If you are, I can hold you for as long as I need to. So how many sig figs should you record here? 3, so that should be 225. Okay, so what's really important to know? The formulas. The formulas, there's really one that combines 3, so you should know the combined gas law, and then what other one that didn't really fit into that? Ideal gas law we haven't talked about yet.
I guess
the very first one. So it's an A. Avogadro's law, because it doesn't really fit in that, okay? So what I need you to finish, you will finish 1 through 16. So we didn't get to ideal gas law, so don't worry about the ideal gas law until tomorrow. My people who you weren't here for the little part, we started the simulation, we got about halfway through. I'll give you guys some time to finish your simulation tomorrow. But tomorrow in class we're doing ideal gas law. We'll make a foldable because the formulas will kind of need to be practiced a bit more. And we'll learn the ideal gas law transfer, so we'll finish the simulation, okay? So, and I have some fun demonstrations for us to try together. Put your laptops up now. Yeah. You find it? You good? I'll upload that video for my people at home.